So the idea fundamentally behind quicksort is this. Say I have an array that I want to sort. What I'm going to do is select a pivot element and then partition my array around that pivot element. What do I mean by that? Well, let's select 8 as my pivot element. I'm going to partition my array into two sides. One that's less than or equal to 8, one that's greater than 8. So let's see what that looks like. I have 4, that's less than. We're going to walk through this array. 9 is greater, 7 is less than. And then we have 3, less than. Next up, my 8 will go here. And then we'll have the things that are greater than 8. So we have 9, 10, and 11. Okay. Now I know for a fact this 8 in the completely sorted array is exactly in the position that it belongs. Why do I know that? I know that because at this side, everything is less than or equal to 8. And this side, everything is greater than 8. So you can follow the logic where if I had this side sorted and I had this side sorted, I'd have a completely sorted array. So this is a job for recursion. We can just quicksort this side and quicksort this side, and then concatenate the whole thing together. So let's see what that looks like. Here we'll choose 4 as our pivot element. Things that are less than 4 are this 3. We'll have the 4 right here. And then we have 7. If we were to quicksort this side and this side, well, an array with just one element in it is, by definition, already sorted. So let's look at this side now. We'll select 9 as our pivot element. Nothing in this array is smaller than or equal to 9, so we'll just leave that there. We'll put the 9 right here. And everything larger is this 10 and 11. Okay? This is not of array length 1 or 0, so we're going to have to quicksort. We'll set 10 as our pivot element. Everything less than 10, well, there's nothing less than 10. We'll have 10 here, and then we'll have 11. So if I were to just concatenate the results of all of these recursive calls, we would just have an array 3, 4, 7, 8, 9, 10, and 11. Completely sorted. So let's take a look at what this would be in code now. All right, so let's write out quicksort. So let's define it. Const quicksort equals a function that will take an array. And what are we going to do? Well, let's first consider the base case. Well, the base case will be if the array is of length 1 or 0, and we'll just return it. So if r.length is less than or equal to 1, return the r. Okay? Now, there's a couple of variables that we're going to need to make sure that we have for JavaScript. So we're going to const pivot, and we'll select pivot as the array at element 0, the first element, just like we were doing in the before example. We'll say the left side is just equal to an array. Oops. We'll say right, again, just an array, and we'll just have something as a result to keep everything in at the end. So now we want to loop through each of the elements, so we'll just use a regular for loop. For let I equals 0. Excuse me. One thing to catch, we don't want I to equal 0. We actually want I to equal 1 because 0 is our pivot element, and we don't need to look at it twice, right? That'll cause some problems. So we'll say I is less than r.length. So we loop through everything, and then I plus plus. Okay, what are we doing in each of these iterations? Well, first, if the r at I is less than or equal to the pivot, well, we'll put that in the left side then. So we'll say left.push r at I. That sounds good. Else, oops, we'd want to do the opposite, right.push r at I. And that should partition our array pretty nicely. And now we finally want to return everything put together. So return result.concat. We want to quicksort the left side, so that'll be quicksort the left. We need to put our pivot element right in the middle, and we need to quicksort the right. Okay, let's see result.concat, quicksort the left, quicksort the right. Save that, and let's test this now. So Let's say let A for our first array to test. Well, let's just test an easy 5, 4, 3, 2, and 1. And we'll have a B, and we'll test that as like, yeah, I don't know, 8, 12, 7, 9, 14, 11, 2000. Cool. And I'm going to test this over a node, so let's just head over here. Let's define our quicksort function. Okay, cool, we got quicksort, and let's define our A. Okay, and we got A, and let's say, let's quicksort it. So quicksort A. And okay, cool. We get 1, 2, 3, 4, 5, exactly what we would expect. Let's try the a little more complicated example with B. We'll just grab B there. I'm just going to clear out, and we're going to run quicksort on B, and we get 7, 8, 9, 11, 12, 14, and 2000. That looks sorted to me, so it works. Yay, and that is one implementation of the quicksort algorithm.